you, Tiago, for the introduction. Hello, everyone. As Tiago said, I'm André. I'll be talking to you a lot about our toolkit that we developed for in the wild data collection and more specifically for text entry data. This is an amalgamation, I would say, of our work from a few years already of working in the field of text entry analysis and also conducting in the wild studies in primarily using smartphones as a way to collect data. So smartphones are everywhere. I think I don't need to say much more. The old feature phones where you had keys to press are disappearing from the market. So even elderly people that traditionally weren't adopters of such technology are starting to have to use smartphones or risk not having a phone. Regardless of what country you're in, even if it's a country with people where people have more or less economical power, everywhere people are using smartphones. And we kind of use smartphones to do a little bit of everything. In many cases, they almost become an extension of oneself. And we are increasingly generating more and more personal data on these devices. So privacy becomes quite a hot topic when it comes to smartphones and specifically collecting data, and more so when talking about collecting data in the wild. And it's really not surprising because we use these devices to do a bit of everything, to work, to socialize, and all sorts of other more mundane activities. And one of the main things that we actually do with them is typing. So we type a lot. We type to browse the web, to work, to socialize, and to shop, among many other things. Some more than others, but typing is a very common task. And we really think that text entry is quite an interesting task and quite a complex one because it kind of encapsulates these two types of demands. You obviously have a cognitive demand when you're constructing phrases and having to make an argument. It varies if you're doing writing formally or informally, if you're writing in your mother language or if it's a language that you're more unfamiliar with. But there's no denying it that there's a cognitive demand to it. And what we find interesting as if we analyze these kinds of cognitive demands on text entry, we can kind of expect that, for example, diseases that have cognitive declines, maybe we can see something on the data that reveals that. On the same token, we have a physical demand because people have to write on these relatively small displays and be very precise with their typing and with their touching. And for people that have a motor disability, or even if someone is more tired, their motor dexterity might be affected. And it can be, again, quite interesting to look at this data because it can reveal, or we believe that it can reveal a lot of things. So what can we actually do with it? So past research has showcased a lot of potential for text entry as a digital endpoint, for example, for both disease detection and monitoring, for biometrics and understanding users individually, for one to actually record themselves and use it as part of the quantified self movement that is out there, in the same way that people collect their accelerometer data to check how they are doing throughout the years or months. And we also see a possibility to use the type of data that we can collect from text entry tasks to personalize a variety of different things, such as the way users interact with the device, whether that would be accessibility options or more fine-grained modeling of users' behaviors and adaptation of interactions. I'll talk a little bit more in detail about some of these. So for example, in the specific case of Parkinson, we already seen past work using typing behavior. So the way people type or their touch behaviors when typing to distinguish between people that have Parkinson's and healthy control subjects, or discriminating between early Parkinson patients and again healthy patients, healthy participants. And both the ones on the top both use touch typing behaviors, I would say, which is basically how people write. So, for example, how much time they take traveling from one key to another, and not necessarily how people are writing or the errors that are making. But some works are already starting to combining these two approaches of both assessing not only how you type in terms of touching behaviors, but having an understanding of the character level or the sequence of characters that you are writing to beef up the types of analysis and the performances of these kinds of models. It's not only Parkinson, we've seen used in other domains as well. For example, typing behaviors have also been able to distinguish between people with multiple sclerosis and healthy participants. In some, I would say, more preliminary work, perhaps, we've seen attempts to distinguish between stress and unstress states with some success, and as well as others looking at typing behaviors as a way to assess fatigue between people having more or being more or less tired throughout the day. And even for inebriation, in CHI 2018, we seen a paper correlating the way users are typing with their blood alcohol level. So related with, of course, this is how they they were exploring how they were their typing behaviors, their touch behaviors on the phone. So we think, again, text can be quite interesting for a variety of different domains or different contexts in the health space. As for biometrics, we have seen that typing behaviors have been mostly explored as authentication or as a mechanism to detect intrusions. And what all of these works have in common is that they suggest that typing and touching behaviors can be highly sensitive to the individual, which can be quite interesting because it kind of shows us the power of using these individualized models for relying on text entry. As for the personalization and about one collecting their own data or the quantified self movement, we've seen examples of how touch data in particular can be used to adapt or to produce models of how the users are interacting. For example, the paper on top used a custom-made application of Sudoku to try to understand how the users were interacting with the smartphone, and then they could adapt based on what they already constructed the model of the user to be, in this case, motor impaired users, to facilitate interacting with the application. Of course, this can be extrapolated. If you have models, you can then start to think about how you can actually adapt not just one application, but the whole interaction with the smartphone. And similarly, specifically on text entry, the work by Wang showed that if we know a user has Parkinson, then we can start to actually have algorithms that facilitate the way they are typing, significantly reducing the errors that participants actually do when writing on smartphones. And well, all of this is really interesting, or again, we think it is. But actually, there's one thing: how can we go about collecting all these types of data? And I'll go a bit through the approaches that prior work has also done. So the way we see it, there are two main ways to collect text entry data. You can collect text entry data explicitly. And what I mean by explicitly is asking the user to do something. And the traditional one in text entry studies, or both in the laboratory and even so in the wild, is to prompt the user to do a transcription task. So you give them the target phrase, and then they simply have to do it as best and as accurate and as fast as they can. These usually require you to build custom-made applications, to have the users install them, and then have generate these kind of notifications for the user. A different approach is actually to collect implicit data. So anywhere the user is writing text, you can collect it. And there have been multiple approaches for this. One of them is actually collect everything. So you can do this by having a keylogger, or if you develop a keyboard that does this, you can obviously do this. And we did this in the past in some of our work. And there are frameworks out there that also are able to kind of act like a keylogger almost. But there's obviously a problem here about privacy. And the problem is that if users know everything they are doing is being collected, they will refrain from participating in your studies, and it will be much harder to actually have people use the devices for long periods of time, unless unless under very specific conditions, or people that are really keen on participating in studies, or that see a clear benefit in using it. But of course, they can be quite powerful if you are able to collect everything. Another type of approach, still in implicit data collection, is actually, well, we do collect everything, but nothing that would compromise user privacy or the content that they are actually sharing. And past work, the way they have dealt with this is collecting metrics that actually they don't collect any text data, nor any data that would allow the reconstruction of the text that participants were doing while typing. And metrics are metrics like flight time and hold time. For those who don't know, the flight time is the time between someone pressing a key and then lifting off and going to the next key. So the time they spent transitioning between keys, basically. Oops. Sorry. And another approach, still in implicit collection, is not collecting data, but obfuscating it in a way that it's incomprehensible. So there have been works. Sorry, there have been works that have been that develop filters. So then we as researchers are conducting the study, we can collect snippets of the data, I would say, but not in a way that would make or enable us to reconstruct the text that was actually written. This obviously has benefits and downsides, or even abstracting the text content. So imagine that you have a sentence, you can analyze the sentence and transform each word into its category. So imagine that you could have like noun, verb, adjective, so you can still get some linguistic level information or language level information, but still not compromise user privacy. So these are also quite interesting and can be quite powerful. So summarizing a bit of the work that I've been discussing so far, all of these have one thing in common. Deploying studies in the wild can be quite challenging, and depending on the types of things that you want to collect, it can present additional privacy issues and result in lower compliance. There's obviously these two sides to the collection. You have implicit collection that allows you to collect everywhere. It can be more spontaneous and probably have more continuous data throughout the day. But with explicit, you can prompt the user to do more control tasks. There's obviously privacy issues depending on the type of method that you choose to do. And there's these, I would categorize these two different types of metrics that you can collect: the touch data, so the way the users are interacting with their device, and the text or language level data, which are more related to how users construct their phrases and how they verbalize or how they write. So considering all of this, we developed the WildKey toolkit, which is a privacy-aware keyboard toolkit for data collection in the wild, considering all that I mentioned before. So our motto was kind of, we wanted to enable anyone to collect everyday typing data that would enable more continuous and spontaneous assessments of how users are doing, without having to collect any sensitive information. thus promoting compliance and adherence to, since participants would feel more comfortable using the keyboard. So the toolkit is composed of three main components, I would say. One of them is an Android keyboard application. Another one is a study manager React application, and a cloud database that we are using one specific one, but the toolkit was developed that you can easily transition to a different one if you so wished. So as for the Android keyboard, it's a traditional Android keyboard, nothing really special about it other than the metrics that we and the analytics that we put on top. So it extends the Open Android software project, and specifically the keyboard. It has language support for 26 languages, autocorrect, suggestions, and all things that you come to expect. And it is available on Android 6.0 and above. As for the study manager application, it's an application that basically allows you to create studies, to manage your users. It has a study dashboard that allows you to oversee the study. And it's one of the parts of the ecosystem that we try to build with this toolkit. One thing that is important to highlight is that the WildKey toolkit was developed in a way that you can deploy your own ecosystem completely separate from our own. So you create your own cloud database and you can deploy your own local study manager application and have a version of your WildKey keyboard to conduct your studies. So you have more control over the studies you are running and the data that you are generating. As for data collection, which is probably the most important point of the toolkit, we have the text entry data collection, which obviously the most important one. And we, since as I mentioned before, it's not clear cut if implicit data or implicit data collection, if one is better or the other, they are adequate for different scenarios. So actually the Wild toolkit enables you to collect both. And part of running in the wild studies, specifically in the health domain, one of the common things that you might want to do during a longitudinal study to actually have points of assessment throughout the study, which typically employ deploying scales or questionnaires to your participants. And as such, we in the toolkit we also have the ability for you to create custom, to create your own questionnaires and deploy them to your users, and also create custom-made tasks or use the ones that we have available. I'll go into a bit more detail into each of these. So for the explicit tasks, we support two kinds of tasks at the moment. So transcription task, which is the default standard traditional text entry assessments where you give a phrase and the users write the same phrase. And we also support compositions, which basically allows you to ask a question for the user and then you collect the data that they are answering. Oops. So there are benefits to the explicit task. As I mentioned before, they can be more control and you can prompt the user whenever you want to do a specific thing. You can use the composition kind of tasks to ask relevant questions to your study. So in addition to collecting the text entry data, you might be interested in their actual responses. And you can kind of force data collection when you do this, while in implicit data, you pretty much are at the whim of your user, of your participants. Also, one thing that we do here, since we are specifically asking the users to do something, we collect raw data in all of our explicit data collection methods. So we collect both all the touch points and all the text that the user has written. For implicit data collection, we support the keyboard collects data anywhere the user writes, and it obviously has other benefits, namely we are analyzing the user natural typing behavior without having artificial tasks created for them to do. It allows a continuous effort without having to add any additional effort to the user. And the way we do it to conserve or to have user privacy is that we actually don't store any textual data. What we do is that we locally process every metric that requires access to the text content, and only the data that is generated that doesn't allow for any reconstruction of the actual text is recorded to the database. So at no point do we store data about what the users are writing, and in this way we can ensure both privacy but still have the benefits of processing the language or the text that the users are writing. As for processing the text and how we actually handle this, so for those of you who are more familiar with text entry analysis, one of the important things that you have to know when you're trying to assess error rates, for example, is you have to know what the user is trying to write. So when you actually give them the sentence to write, you know what they're trying to write. But for methods such as the implicit data collection, or for questions that you ask to your users, you don't know what they're trying to write. So you have to do a probabilistic approach and estimate what they are trying to write. And we do this in a similar way to how Evans did in 2012 and how we did in a past work of ours in text entry in the wild as well, where we basically use the dictionary to find if the words that result in your on your final sentence, we check if there's a word for that in the dictionary. If not, we use the best estimate as your intent. If there is not a word for that, we just assume that you are using a word that you invented and you're pretty comfortable that's the word that you were trying to write. We also support the unconstrained text entry protocol. What this means is basically users don't have to have a certain kind of behavior to use the keyboard. They can correct, use suggestions, move the cursor and change sentence in the middle, and the keyboard handles all of those changes and then is able to still process and calculate the metrics that we are able to have. As for the questionnaires, we have a variety of different types of questions that you can create. These are examples of 4 different types of questions. There's not much to it other than you can create them and deploy them as you wish. As for, I'm always going backwards, sorry. As for the custom-made tasks, one thing that we know is that when running studies, every study is normally a little bit different, and normally those changes are the ones that cost you the most to implement. So we try to do the toolkit as much as possible to be extendable. And one of the ways that we did is by implementing what we call a custom-made kind of tasks, where if you are more technical, you can create your own custom tasks and still deploy them through the toolkit. Where we have one example currently available, which we implemented the alternate finger typing test, which is used for assessment of bradykinesia. Can't say that word, sorry. But obviously, depending on your context, it might make sense to have other types of digital assessments. Again, I'll touch a little bit on this throughout the presentation, but we designed this to be a privacy aware toolkit. And one of the ways that we did it was by ensuring that during implicit collection, we don't actually store any text content, and we make sure the users know that. We also don't process anything that when the users are writing in password fields or when inserting numbers, because normally those two are really sensitive. We also have always available on the keyboard a small lock icon on the top left corner of the keyboard, where users can basically enable a mode where nothing is calculated. Sorry, and this is also is based on Research IME, who also used a similar approach to give users the freedom to enter a private mode. On our study dashboards, we also have some tools that enable or facilitate the right to be forgotten. So you can download all of the of one user's data and send it to them if they request, or delete all the data associated with one particular user more easily, at least from the database. We have on our repository mockup data reports, which are basically a template of the kinds of data that we are generating. And we highly encourage anyone that uses the toolkit to either produce similar ones or to use these ones when you're running your studies, because we found that when you give these to participants beforehand, they are more keen to participate in the study and feel more comfortable with because they understand the types of data that you are actually collecting. One thing that we actually also do, and we encourage everyone to do as well, is at the end of the study, we take the data that participants have and we generate a similar report to the mockup one, but with data that they themselves contributed, and we give them back to them. Does people benefit from participating in these types of studies, understanding more of their text entry behaviors? It's a nice addition to the study. And also, again, feel more comfortable with the data they are sharing, and they can see the outcomes of what they have been, or at least a glimpse of the outcomes of what they've been sharing. As for running your study, I already talked a lot about this as well, but basically in the study dashboard or in the study manager app, you can personalize the kind of studies that or the types of tasks you want the users to do. You can create schedules for one user or for multiple users and deploy them. For example, a study that we are currently running, we have a schedule that participants have questionnaires every weekend for 4 weeks. And during 2 of those weeks, they have 3 times of one task 3 times of day in 3 defined intervals. And the way this actually goes to the user is on their smartphone. They get notified whenever they enter a period where they have a task available. We have a small notification also available on the keyboard to facilitate users reaching the task as well. And through the application from the keyboard, they can also go to the task and see when it's their next pending, or when will the next task for them to do will be available. This for, of course, the explicit tasks such as questionnaires or explicit text entry tasks. Can also manage your users and have a quick access a study dashboard to check some of the metrics that might be helpful while you're running your study. I won't go into too much detail about the metrics that we collect. We collect over 15 metrics. In the end, I'll share with you a link to our website for WildKey, which has also a link there for a technical report that that is there available, which specifically details how each of the metrics is calculated and points you to related work on them when necessary. But overall, we collect speed, errors, and others that I'll talk in a bit, just to give you a quick glimpse of the types of things that we can then see from the data. This is, for example, one participant from our most recent study. Here we can see each dot is a text entry trial. So opening the keyboard, writing something, and then closing it. The red dots are the average. And we can see, I think, almost 4 weeks of data, if not more, of a single participant, which obviously is someone that writes quite a lot. Again, the same type of graph, but this time for error rates for a particular participant as well. And here you can see that some sessions, and it was the same in the previous one, where there are some that are quite outliers. And those happen when, for example, a user either writes something that is completely rubbish, I would say, or if someone quickly opens the keyboard and taps 2 or 3 suggestions and then sends it. Of course, the text entry, for example, the words per minute will be quite high, even though there were only two presses. So there are other metrics that can compensate for that. This is an example from our past work, and with the type of data that we are collecting in WildKey, you can do these sorts of visualizations to better understand what you're looking at. In this specific case, is looking at the substitution error rates. So which keys are mostly responsible for substitution error rates, and this can, depending on the context, be quite relevant to look at. We also collect touch dynamics or typing behaviors, as I was talking before, from flight time to hold time to a variety of different ones. The ones that we don't collect in implicit are the ones that would allow you to reconstruct the text. And from these, again, you can, depending on what you're trying to look at, it can be quite interesting to do. Sorry, I think my headset died. Can be quite interesting to do. So on the bottom image, you'll see this was a study that we ran a couple of years ago where we had blind participants and we gave them a smartphone for the first time and accompanied them throughout, I think it was 8 weeks. And on the bottom image, you see their all times from the first week to the last week of one particular participant. So you see a clear improvement and where the focus problem points for that particular user. Again, we collect a bunch of different metrics around action and character counts, how many entry actions, how many correction actions, autocorrects, and so on, which again, depending on what you're trying to assess, it can be quite relevant. This is just, again, a quick graph of the characters written per day for one participant during implicit data collection. So you can see this is quite an active user with some days with one day over 3,500 characters, with which is quite impressive, I would say. There's obviously some trade-offs. So at the moment, we only support Android 6.0 and above, which is about 85% of the Androids available. The error rates on implicit collection, as you might have noticed, are artificially inflated. And this is, of course, because people, when they're writing more informally, they use abbreviations, they use emphasize words in different ways, and all of those are considered as errors, even though they might not be. There have been past works also assessing these differences between in the wild and laboratory studies on text entry, which indicate this kind of difference and establish these types of differences quite well. Of course, accuracy can vary depending on the questionnaire, on the dictionary, or the language that you're using. And finally, currently, the deployment of our ecosystem of the toolkit requires some amount of technical expertise. We are more than happy to guide you through it in case you are interested in. We are working towards a model that allows anyone, a clinician with no technical expertise, to deploy this and run their own studies. But the toolkit, it's not there yet. It's still it still requires some technical expertise to deploy the whole ecosystem. We will have a standalone demo available on the Play Store sometime next week with only local storage, so you can install and check the type of metrics that we can collect. There's also on the website I'll share, there's also a link to multiple sample files of the data we collected as well. So just to before finishing off, we are currently already using the keyboard in three studies that we are working on. The first one is on exploring privacy, adherence, and compliance around these different types of data collection and how participants feel, what types of data these different methods are generating, which ones are interesting. With our partners, we are exploring also text entry metrics on Parkinson, and we are interested in, we are preparing a multiple stage study where we'll go into more detail about the differences or the motor fluctuations in Parkinson and try to assess those with text entry metrics or touch behaviors. And finally, with our partners, we are participating in a study where the keyboard will be used, or I think starting next week, exploring text entry metrics in fatigue. So I won't bother you anymore. I think I'm a bit over time. I just want to say you can contact me or reach out to us if you're interested in using this and running your own studies. Please let us know. The repository is open source and open to everyone. Currently, we still require you to send us a message before we give you access, but we give access regardless of whether you want to do it on your own or collaborate. But we are very keen on exploring new opportunities and collaboration, so feel free to reach out. So thank you everyone for listening, and I'm open to questions.
So thank you, André. And so I'll open the floor for questions. I won't make them unless I have to. Does anyone have a question for André?
Hello, I have a question. Thank you for the presentation, André. Why is the accuracy different for different languages? Can you talk a bit more about why that happens?
So we actually don't know. That was the point I was trying to make. So we have some experience with running this with Portuguese and with English, and they seem to be pretty all right. But you might run into some issues depending on the dictionaries that you're using. One thing that we notice even on our own dictionaries is if the word is there, usually that's not a problem. So it's a dictionary. So if the word exists, that's okay. But if you rely on the prediction of the dictionary and the spell checker to actually estimate the word, the better they estimate, the better will be your calculation of your error rate. So since we are relying on open source dictionaries and spell checkers, these might, for example, if you are using a dictionary for a long time and you add your own words to it, the error rate will decrease because it's personalized to you. While if you have one that does not have those, it will obviously increase if you are just bootstrapping and using it. So that's just one thing to consider. Also, one thing to note is we currently don't have an easy way to add additional dictionaries because it requires a little bit of work on the back end. But that's something that you can do if you are more technical. You can provide your own dictionaries and use your own spell checking methods to check for or estimate the word.
Thank you.
No problem.
Do you have more questions?
I have one.
Hi.
Thanks for the talk. It was nice. So I'm wondering if you are aware of some interesting typing features that tell us something about the psychological state of the user. Because I'm not really sure what to look for if that's what we're interested in.
So a couple of those. So for example, depending on what you're trying to assess, for example, looking at the text that the participant is actually writing, doing some kind of sentiment analysis might be indicative of the state, and trying to assess the emotions conveyed in the way people are writing could be interesting. That's something that you can build as a local analysis to the text when you're collecting implicitly. In the current metrics that we are supporting, we've seen in past work that people, for example, when they are more stressed, they tend to write faster and with more errors. So I'm not sure which ones will be the ones that will be interesting to look at, but for example, old times on the keys might also determine if the user is more uncertain of writing a letter or not because he's more concerned about something. So there are subtle changes, but if you collect enough data, it might be interesting to look at. I don't know for sure if they'll give you something, but I think they're promising to look at the very least. Did I answer your question?
Partially. It's not a topic that we have really worked on so far. I'm just thinking about it, and these are good pointers. If we actually want to do something about this, we'll have to research it a bit further.
Another thing that I can say is if you want to look at more if you want to look at the data as how much people are socializing, that can also be indicative of people having some issues. So if you are collecting how many text entry sessions they have, you can kind of see their patterns, and you can maybe notice if there's differences in some weekend. All of a sudden they didn't communicate with anyone for a whole day. That's not normal, right? So it kind of depends on what you're looking at, and yeah.
Okay, thank
But
you.
very interesting question that I also don't know the answer.
I have a question too.
Hi there.
Hi, Andre. How do you aggregate your metrics? Is it by typing session, by minute, by day?
So currently, the way we do it, every time you open the keyboard, we consider that to be a session. And when the user closes it, then that ends the session. There's obviously one potential issue, which is if people open the keyboard and don't write anything, or they stop in the middle and then open it after, or resume it a couple of minutes afterwards. And we are going to segment those instances where there's, or we will enable you to personalize how much time do you wait before you consider a session to be over, even if the keyboard is open. But that's basically the way that we are currently doing. So we're collecting everything, and then since you have the sessions per per time that the user opens and closes, then you can aggregate per day if you wish to.
Makes sense. Thanks.
No problem.
So one more question here, and thanks Andre for the talk.
Yeah.
I wanted to ask a kind of a general question, really, because I saw that you mentioned several studies that used smartphones for, let's say, discriminating between healthy participants and those with Parkinson. Mm-hmm. I don't know if you've done a study like this or not now.
We are working on one now.
So, okay, good. So then my question is, are you aware of any studies that have, for example, compared a signal that's coming from accelerometers and the signal that's coming from a keyboard like yours, and which one would have perhaps more discriminative power, or a combination of both, I assume, would be the best. But out of these, are you aware of any studies that have done something similar?
I'm aware of studies that use the accelerometer on the smartphone to actually calculate that. One that combines both, I'm not sure if I come across one yet. Of course, the accelerometer data particularly for Parkinson's is very I would say it's probably considered one of the most promising digital endpoints that people are using at the moment. I would expect typing can be complementary or used in different ways if you're if you don't have access to a wrist accelerometer and only using your phone. I can see it improving the types of accuracy that you're reaching, and but yeah, I haven't come across, but that might be some interesting work to do.
Yeah. Okay. Thanks.
Thank you.
Hello, Andre. Thank you for the presentation. One quick question regarding what you were talking about in the past 2 questions ago, I guess, regarding using the keyboard to check if the person was active communicating with someone and so on. That raised me a question of, is the keyboard aware of to what application is he writing to?
Currently, no, for privacy concerns. So we don't want to say that we collect how much time you're spending on Facebook or whatever. But but if you know, there are some traits when you're writing on the keyboard that you know that you're writing for someone. So if you're doing a browser search or writing a shop list, your text entry trials will be for rather short. If you are composing long sentences, you can expect that to be more related with social applications. That's not to say that you cannot or that we cannot combine this with other services that are collecting already that, and then you can cross-reference you know he was typing in this session, and you have some other information from other sensors knowing that that the user shared with you what application they were using. And yeah.
Okay, thank you.
Okay.
Hello.
Do you have more questions?
Yeah, I have one more question.
Go ahead.
Can you hear me?
Yes.
Yes.
There is a framework called Aware Framework.
Yep.
What is the advantage of WildKey over Aware Framework?
So the Aware Framework actually provides a lot of different sensor data. Well, I didn't put up the link. I thought I did, but the way that Aware Frameworks does it, as far as I'm aware, is they collect a bunch of different sensors from the smartphone, and one of those can be the keys that the user is pressing. So it's basically a key logger. So you don't have any touch dynamic information. And as far as I'm aware, since you are collecting text entry data, I think they don't collect in password fields and also numbers, but obviously you're compromising user privacy when doing so. I also think they are just a keylogger. So if you're just interested in the text entry data of the input sentence that the users are writing, it can be a solution. But if you want more finer details that you can get from collecting also typing touch behaviors or tapping behaviors like hold times and stuff like that, I think they, as far as I'm aware, they're not able to get that level of detail.
Thank you.
No problem. Thank you.
Hi, I'm
Still have time for questions?
Yeah,
Yes, go ahead.
I have a comment and also a question. So first of all, I really liked your advice with regarding how to sort of convince participants to install something like this. I think giving them some control and some transparency, that was really good advice. I haven't thought about this, so thank you. But I also have a question. I think it's related to the first question. So when typing in Slovenian, we have some special letters, which I'm sure is the case in other languages as well. And you can access those letters by a long press on a certain letter, unless you actually use a specific keyboard. But yeah, I find this is not the most common usage pattern. So I was wondering whether you take into account these long presses in any way and how.
We currently check to see if users are using what we call special characters. Sorry, I'm not sure if the ones hidden behind long presses are considered such ones. Are considered ones. I would have to check, to be honest. But if they are, we are kind of counting how many special characters someone uses it. As we extended the Android keyboard, the default Android keyboard. If there's support for your language, your keyboard should support it as well. As for the touch dynamic or the touch metrics that we collect, you'll obviously see some hold times in some particular keys being or in some particular sessions being more than. Let me try to say this. So we collect every letter that you enter. We collect your hold time on the keyboard for that particular letter, and we know what is the hold time to trigger the long press. So we can actually kind of determine when you are using a long press interaction on your keyboard, because we know that part. We don't know inside which letter you wrote, but other than that, we can sort of look at that data. Of course, this is always, I'm always talking about implicit data collection, because if you actually send a transcription or a composition task for your participants, then we collect everything raw. So then you can do whatever.
Thanks.
Thank you.
Time for a last question. Are we happy?
One last question then.
Yes, go ahead.
Have you had any issues deploying this to a particular Android phone, like brand? And are there any plans to port this to iOS?
So iOS normally is a bit more restricted with their with the permissions that they give to the users. Last time I checked, I think it starts to become possible to actually run this kind of keyboard applications on iOS. We currently don't have plans for the short term to support this for iOS, but it's something that we have on the back of our minds that should be available. As for the Android, we are we have planned for, well, in a couple of months, hopefully, we'll be looking at trying to see if we can reach Android 5.0, but there are some dependencies that we are not sure we can deal with losing at the moment. So I think we'll probably, the support for Android devices will be from 6.0 and above, which covers 85%, and that number will obviously increase. But I'm not sure if that was your question regarding Android.
It was more regardless to, because sometimes with, for example, with Aware, some Samsung phones have issues, and sometimes some Huawei phones have issues. So I was wondering if you have found any particular brand or phone that has had issues with.
That's a tough question to answer, because from the phones that we ran so far, we had some phones. So Samsung gave us a little bit of trouble, and you had to compile stuff in a different way to actually get it to work or be supported when we deployed it to the Play Store. Other than that, we have seen some differences in the not in the data collection, but in the what am I seeing? Sorry. But in the visualization of notifications. So notifications are kind of an issue because different Androids deal with the notifications in very different ways, and they can completely shut down your application from showing those. So for explicit tasks, we've seen some differences, but we've been trying to address all of those. And at the moment, I cannot pinpoint you one that is a particular issue that we are not aware of how to solve.
That's great. Thanks.
But thank you.
Okay. Thank you, everyone. Thank you, André. Before closing the session, I would like to call your attention to our next seminar in 2 weeks. And if you want to register for this seminar, we'll open the registrations soon. Check our website, widehealth.eu, the website of the project, and it will appear that there are all the details and how you can register for the next one. And I hope that you all can join us in this series and continue to create this network of research around pervasive healthcare. And so, thank you, everyone, and have a good afternoon.